Hello kids, Mr. Agee here, and I'm here to talk to you about your assignment in math for Tuesday, November 10th. You'll click into the Week 13 Math and Word Study with Agee folder and into the math folder and into Tuesday, and you'll see that there is a Lesson 17 problem set and Lesson 17 homework. Now the focus of these lessons today is on looking at um, addition equations in the hundreds and practicing both mental math and standard algorithm to solve for actual sums, which means exact sums, and comparing it to estimated sums. So when you estimate the sum, all you're going to be doing is rounding to the nearest hundred. So when I open up this lesson 17 problem set, you can do this in your green workbook. I've already populated some of these with some mental math that I did, and I also showed the strategy for setting up the standard algorithm. Um, this first and second problem, the first 1A with the three tables A, B, and C, and then B. It's kind of convoluted, and they give you a lot of things to do here. I do encourage you to get the practice of doing the mental math of adding up numbers like this, and also the estimations by rounding each to the nearest hundred. But they ask you to do some really sophisticated stuff here. And so what they have you doing here is finding the exact sums of the numbers, and then underneath rounding each add-in to the nearest hundred and finding an estimated sum. Then, so they ask you to do that one, two, three times with three related sets of add-ins, and then one, two, three times with three more sets of related add-ins, and then one, two, three more times with three sets of related add-ins, and they want you to find a pattern. It tells you at the bottom of each table here to circle the estimated sum that is closest to its real sum. So you can see the real sum here is actually 700. Well, the estimated sum is actually 700 as well, so that's going to be the closest to the real sum. And what you'll notice up here is that the estimated sum is actually kind of far off from the actual sum. And again, down here, the estimated sum is kind of far off from the actual sum. So what it's asking you to do in part B is to look at the sums that gave the most precise estimates, the ones that you circled. So this one here is 500, and it's very, very close to 504. And it says, explain what they have in common. You might use a number line to support your explanation. Well, this is really super challenging work, and if you want to do this and come up with a really sophisticated explanation, then you can, but I'll tell you the gist of it here. So if you look, all of the numbers you're adding are near the 50 within the hundreds. So 451, 253, very near to 50, both slightly above 50, which means they're both going to round up. Here we've got one that's above 50 slightly and one that's below 50 slightly. So one's going to round up to the next 100 and one's going to round down to the previous 100. And then down here, the third example, both add-ins would, because they're slightly lower than 50, would round down. So you end up with a number that's significantly lower than the actual sum. So the only example that gives you a good estimation is when one of the add-ins is slightly above and the other add-in is slightly below the 50 mark. And it works the same way as you go across. One is slightly above, or in the top example, both are slightly above 50. In the bottom example, both are lower than 50. In the middle example, one is above the 50 and one is below the 50. So the one that's has the one above and one below is going to give you a closer estimate to the actual sum, because you're not rounding. You know, when you round, let's use this first example, from 451, it technically rounds up to 500, but you're going 49 up to get to that 500. And then in the next add-in, you have to go 47 up to get to the estimated or to the rounded 100. So you're ending up going up by nearly 100, and that's why your estimation is nearly 100 off. So they're trying to get you to make that connection. I don't think that it's the greatest way to do it, but what I look at this as is a good opportunity for you to get practice with your rounding and to to also get practice with mental math skills for finding actual sums and using the standard algorithm for finding actual sums. I would put much more effort into this top section here than in giving an explanation in B. And if it's too much for you, just ignore it. Don't even do it. Part B. I do want you to get the practice of adding the numbers to find an exact sum and also rounding each add-in to the nearest hundred and finding an estimated sum. Moving on in the assignment, in the second part, you've got some constructed responses for story problems. So you're basically going to be reading these stories, and in one situation, they ask you to decide how to round. That means, are you going to round to the nearest 100 or the nearest 10? And whichever way you round, you got to do it for both numbers. So if you're rounding to the nearest 10, you would be rounding this one to 90 and this one to 150. If you're rounding to the nearest 100, you would be rounding to 100 and 200. So you can see when you round to the nearest 10, you're going to get closer with your rounding than if you were to round to the nearest 100, because you have to go farther away sometimes. Like for this example here, if you round to the nearest 10, you only change the actual number by literally 1 minute. But if you rounded to the nearest 100, you change the number from the actual number 151 all the way to 200 minutes, which would be changing it by 49 minutes. Okay, so they're trying to get you to recognize that when you round, you can get closer or farther away depending on how you choose to round. So if I'm rounding to the nearest 10, I'm going to be staying relatively close to the actual sum. If I round to the nearest 100, I might be losing some precision. I might be losing some exactness, and my estimated sum might be kind of far off from the actual sum. So working through this problem, Janet watched a movie that is 94 minutes long on Friday night. She watched a movie that's 151 minutes long on Saturday night. Decide how to round the minutes. That means to the nearest 10 or the nearest 100. Then estimate the total minutes Janet watched movies on Friday and Saturday. So estimate the sum. So write an equation. It might be 90 plus 150. It might be 100 plus 200. Those would be your two choices here. And then how much time did Janet actually spend watching the movies? That means solve the problem 94 plus 151. Use the standard algorithm. Practice using it. Practice carrying. I'm noticing with the in-person students, not everybody's got their strategies down pat, and they need the extra practice for using the standard algorithm correctly, making sure you're carrying appropriately when you need to, and not carrying when you don't need to. And then in the end, they ask you to give a little explanation about whether or not your estimated sum is close to the actual sum. Then it says round in a different way and see which estimate is closer. Well, I kind of just gave away the story here. If you round to the nearest 100, you're probably going to be farther off than if you round to the nearest 10, because you're not changing the numbers nearly as much in your rounding. So in number 3, it's the same kind of deal. You know, they ask you to do an estimated total weight, and then they ask you to do an actual weight. So it's practice with rounding, it's practice with adding, and it's practice also with reasoning. When you get into the homework, it's the same kind of deal. They give you different scenarios and ask you to estimate totals and find actual totals. And so they're in the first 2 examples, A and B, they're asking you to round and add the weights and then find the exact weights, 32 and 7. And then for C and D, they're asking you to round the times, 36 and 25, and then find the actual sum of the times. And then explain how estimating helps you check the reasonableness of your answer. So if you estimate, the idea is when you round, especially if you're rounding to the nearest 10, you should be getting close to the actual answer. And so it's really useful in real life. If something takes 24 minutes and another thing takes 31 minutes, you can say it takes about 20 and about 30. It should take you about 50 minutes. You know, people work together and communicate together, and they use rounded estimates much more frequently than exact numbers. So it is a really useful life skill to be able to do this. And then moving into the last part of the assignment here, it's more of the same. They're asking you to use reasoning skills to round either to the nearest 10 or the nearest 100, and find the sum that way and compare it to the actual sums. Okay, so I hope I gave you the gist of it well enough for you to be successful in this assignment. Get as much of it done as you can. If you run out of steam, then just make sure you're using your math time to do your math assignments, and then when you get to the end of your math time, you can call it a day. If you've got steam and stamina to go on, then by all means, challenge yourself to get it all done. Good luck. I'm wishing that you are all healthy and happy, and I'm looking forward to seeing you again.